Welcome. In this video, we will demonstrate the process of steam distillation, a widely used technique for extracting essential oils and other volatile compounds from plant materials. Steam distillation is used to isolate volatile substances that have high boiling points. When two invisible liquids are distilled together, the boiling point of the mixture is lower than that of either of individual components, therefore high boiling compounds which can decompose before they boil if heated alone. If heated alone, can be distilled at temperatures below 100 degrees Celsius by using this process. The mixture will boil at a temperature slightly less than the normal boiling point of water. This assures that the evaporation of essential oil takes place under mild conditions. We will guide you through each step of the steam distillation process, from preparing the plant material to collecting the distilled essential oil. By the end of this demonstration, you will have a clear understanding of how steam distillation works. The tools that we'll utilize for the experiment are three-way connector, condenser, round bottom flask, clamps, rubber tubes, cloves, distilled water, spatula and Erlenmeyer flask. This is the setup that is used in steam distillation. We will begin the experiment slowly pouring the clove into the round bottom flask until it is halfway full. Then slowly pour distilled water into the flask until all of the clove powder has been drained. Next, take the adapter that fits the mouth of the round bottom flask. Spread grease around the fitting sides and secure it to the round bottom flask. The purpose of adding grease is to prevent evaporation at the joints. The open end of the adapter is sealed with a cork to prevent heat convection. Then carefully install the condenser and adapter. Place the Erlenmeyer flask under the end adapter to collect the distillate. Attach the rubber tubes to the condenser. One tube is for draining water while the other is for filling the condenser with water. By allowing water to enter from the lower hole, the chamber fills completely before the water exits, ensuring better cooling. Direct the Bunsen burner beneath the tripod. Turn on the water supply to the condenser. Start the experiment by heating the bottom flask. Allow the clove to boil for a bit. Soon you will see little drops flowing through the end adapter connected to the condenser. When about 75 to 100 milliliters of distillate has been collected into the beaker, turn off the Bunsen burner and remove the flask from the setup. Now let's proceed to the next step of the extraction process using dichloromethane. Transfer all the distillate into the separatory funnel. Add sodium chloride and 5 milliliters of dichloromethane. Swirl the contents of the separatory funnel while releasing the pressure that builds up using the stopcock. Continue shaking for about 3 to 5 minutes. Clamp the separatory funnel to allow the layers to separate. Separate the two layers and collect the lower organic layer into a clean conical flask. Carry out the extraction procedure 2 more times for better extraction and collect all 3 organic layers. Next, add anhydrous sodium sulfate into the organic layer as the drying agent and swirl it thoroughly. Repeat this process until the organic solution begins to freely swirl. After that, take a funnel and insert a cotton wool swab into it. Secure it in a ring clamp and filter the organic solution through gravity filtration to remove residues. Take an evaporation dish and measure its weight using an analytical balance. Then measure the evaporation dish with the filtered solution. Place the evaporation dish in a water bath. After evaporating the dichloromethane, measure the evaporation dish with the extracted oil. Finally, pour the extracted oil into a tube and label it.